Hello and welcome back. In this video we'll be working through an example where we evaluate a limit of a function at a boundary point of its domain. So the first thing I want to do in this problem is work out what is the domain of this function. I see we have a quotient of two functions, so I need to make sure the bottom is not 0. That's where I'm going to get my domain from. So let's see. So the bottom is 0, square root of x minus 2 square root of y. Is equal to 0. That implies what? Square root of x equals 2 square root of y. So here we need x and y. X and y are both greater than or equal to 0 here. Right, we need that to be true. And then I can maybe square both sides here. I get x equal 4y, or y equals 1/4 x. So what's my domain? So domain, well, it's all points x, y, and R2 such that y is not equal to 1/4 x. And we have x, y greater than or equal to 0. X greater than or equal to 0, y greater than or equal to 0. So there's my domain. And notice this point, the xy goes to 4, 1. So if I investigate 4, 1, that is not in the domain. So okay, so I'm going to graph this. I'm going to graph this domain together with the point 4, 1. So I did actually mess up when I was drawing this because we have, so this is also, say that's, we have x greater than or equal to 0 and y greater than or equal to 0. So these are also all boundary points along this. And so my region is all this stuff over here. Except for this line, y equals 1/4 x. So I've done that as a dotted line. All the points along this line are boundary points because any little open disk around them contains a point on the line, which is not in the domain, and points not on the line, which are in the domain. So those are all boundary points, and the point 4, 1 is on that line, right? If I let x be 4, then y is 1. So that point 4, 1 is not in the domain of the function, but it is on a boundary point of the function, which means we can evaluate, or at least we can try to evaluate a limit as our point goes to 4, 1. The idea here is, right, we talked about limits. The idea is along any path to that point. We want to consider all paths along that point. But when we're doing a limit at a boundary point like this, we rule out, we say you can't approach the point along something not in the domain. So we don't consider paths along this line going to the point. Just paths that are strictly within the domain and head to the point. That's the idea. So how do we actually evaluate this limit at the boundary point? The fact that it's at a boundary point means it's going to be a little bit more interesting. And the idea is we can't use direct substitution yet. However, we can do a little bit of algebra and reduce this function a little bit. Right? We try and cancel things off until we can use direct substitution, just like we did in, say, Calc 1. So what can I do here to start off with? Well, I could multiply this. Yeah, maybe it's been a second since you computed limits, but I could say multiply top and bottom by square root of x plus 2 square root of y and try and cancel these things off. Right? This is a technique from Calc 1. I'm going to multiply top and bottom by square root of x plus 2 square root of y. All right, well, what's that going to do for me? My domain kind of leached in over here, so I'm just going to try and do that. So this limit is equal to, I still have the limit as xy approaches 4, 1. And so I'm not gonna distribute up on top. That's gonna cause a lot of hassle for me if I distribute this. Remember things like that from Calc 1, from doing these. You don't want to distribute that top one. But down here, now I'm going to have a difference of 2 squares. square root of x and square root of and 2 square root of y squared, right? Because I have minus plus and the same terms being multiplied. So what I'll get here on the bottom is, if you want, you can do that out. I'm going to use the difference of two squares formula, x minus 4y squared. All right, that's pretty cool. I'm going to save myself a little bit of room here. Notice that I can find x minus 4y squared. Oh, sorry, not 4y squared, just 4y, right? Square root of y squared is just y. Notice I can pull out, if I pull out a y here, I'll end up with x minus 4y. So I'm actually going to save myself some room and just talk through that and rewrite it. So I'm going to pull a y out of it, and that's going to give me x minus 4y here. So now I can cancel that factor and this factor and end up with, so still evaluating a limit, xy goes to 4, 1 of y times square root of x plus 2 square root of y. Now I have something whose domain is all of the real numbers, and I can evaluate the limit as x goes to 4, 1, right? It's no longer at a boundary point, and I can do this by direct substitution. So plug x equal 4, y equal 1. So that's square root of 4, that's 2 plus 2 times square root of 1, that's 2. So this is, what, 2 plus 2? Just 4? Yeah. All right, so what does this mean? This means that along any path, so the function values approach 4 along any path to the point 4, 1, except for the line y equal 1/4 x over 4, I'll write it as, because that one's outside of the domain. But along any other path to 4, 1, right, any other path in the domain that goes through 4, 1, my function values approach 4. That's my limit. So that's the idea. That's how we can do a limit at a boundary point. Yes, it's very similar to Calc 1. We just have two variables floating around, so that makes it look a little bit different, but the idea is the same. The idea is to cancel, try and cancel out factors. You might have to multiply by conjugates. Cancel out a factor till you have a function that you can use direct substitution on, then use direct substitution, and that's the limit at that boundary point. That's the idea. All right, in the next video, we'll work a slightly different example. And in this one, I'm saying right off the bat, the limit doesn't exist here, and we want to prove that the limit does not exist. We want to show why that happens, why this method that we just did over here fails. All right, I'll see you there. It'll be a fun one.